Okay, logarithmic differentiation. So there's a nifty little trick to taking derivatives of things where you can take the natural log of both sides and simplify your problem down and then take the derivative of both sides. Here we could just use a chain rule and quotient rule, but I think we're going to use this natural log trick instead. So the first step is to take the natural log of both sides. ln x minus 2 over x to the 8th plus 2. Okay, and now we use our log rules to make this right side easier to deal with. So if we remember, the square root is the 1/2 power, right? And we know we can bring this power out front of the log. So that becomes 1/2 ln x minus 2, x to the 8th plus 2. Okay. Then we know from more log rules that we can split this up. You know, let's do this. Let's bring the 1/2 back in there, the 1/2 power, because I think this is going to make our life easier if we had never taken that out, because now we have ln of x minus 2 to the 1/2 minus ln of x to the 8th plus 2 to the 1/2. So here we just used our division property with logs to turn that into subtraction. And you know, then we can bring our 1/2 out front. So really it didn't make any difference. But as we can see, we've gone from quotient rule and chain rule to something much easier. So now what we do is we take the derivative of both sides with respect to x. So let me just be proper and write this out. 1/2 ln x minus 2 minus 1/2 ln x to the 8th plus 2. Okay, so this just means we're going to take the derivative with respect to x. And remember, we're trying to differentiate the function, which is f prime of x, which is the same as dy over dx. So don't forget this. That is our goal here. So if we take the derivative of this side with respect to x, we have a chain rule because of the natural log. So the derivative of natural log is 1 over the inside, so 1 over y, times derivative of the inside. And the derivative of y with respect to x is going to be dy over dx, or f prime of x. Same thing. Okay, that side's done. Now let's do the other side with respect to x. And everything over here is an x, so this is just basic derivatives. So we've got our 1/2, and then the derivative of the natural log with chain rule is going to be 1 over the inside. And the derivative of the inside is just 1, so we won't write it. Minus 1/2. Let's do more chain rule. Derivative of the log is 1 over x to the 8th plus 2 times derivative of the inside, and that's going to be 8x to the 7th. And that is that derivative. So remember, we're looking for f prime of x, or dy dx, so all we have to do is solve for it. And if we multiply both sides by y, we will have done that. So dy dx equals this side over here, so that's going to be 1 over 2 x minus 2 minus 8x to the 7th over 2 x to the 8th plus 2. And you know, while we're here, let's just turn this into a 4. Okay, so now, and remember we multiply both sides by y, so y. So technically this is our answer, but we don't want our answer in terms of a y here, so we wanted everything in terms of x. So keep in mind, y is literally given here. Y equals that. So if we just slap that in from our original problem, we can replace the y with square root and x minus 2 over x to the 8th plus 2. Okay, and that is the answer. So that is logarithmic differentiation, and it has a lot of applications to make chain rule and quotient rule and things go away. It's going to always give you a pretty long answer though.